Alright, Physics 40B, welcome back to another and one of the final explainer videos of the quarter. Let's get right into this. I literally cannot wait to get over with these. So this is explainer video number 19.19, and I think this one goes over week 7 and week 6 this week. It's just week 7 and week 6. But in this one, basically, I'm going to go over like the first law of thermodynamics. We're going to do like conservation of heat and stuff like that. So that's how this relates to this week's work. Like I said, this is 19.9, so try to do the right video. So here's a question. So we got two cars colliding in a head-on collision. They're both traveling at 80 kilometers per hour. That's going to be a problem because kilometers per hour is not base unit, so we got to convert that later. So we're also going to suppose that their kinetic energy is transformed into thermal energy of the wrecks. So we're going to assume that KE is equal to Q. All right, cool. And then what is the temperature increase of each car? You can assume that each car's specific heat is that of iron. So the car's going to have a specific heat of iron. We can Google that, and we just need to calculate the change in temperature. So let's do it. So we're going to start off with the figure. So we have a road, right? We got a road, and we got our two cars. We got a yellow car and a yellow car and a red car. So when they crash, they make an ugly orange car. And when I say orange, I mean this kind of orange. So let's get philosophical here. I just want to remind all of you guys that you all have potential. Psych. Okay, so this is the kinetic energy equation. So when we think about it, we have two cars. So we're going to add those two kinetic energies together. So this was tricky for me because I don't know why. I guess I kind of just like forgot that 1/2 plus 1/2 is 1. But anyway, so here it is. Just reminding you guys. So we have two cars, so they both have their 1/2 mv squared. We're going to add them together, and we're just going to get mv squared. Nice. Okay. So now we're going to go to heat. Not this heat. Not that kind of heat. Not that one. Close, but no. Nope, nope. No, this one. There we go. So Q equals mc delta T. C is specific heat, and delta T is change in T, and then M is the mass. Wow. So, I don't think that was supposed to be there. Sorry about that. Let me just get rid of that. Just get rid of that. Excuse me. All right, let's present that again. Sorry about that. So we're going to add the heat. So like the same thing, we have two cars. So since we have two cars, we get 2 mc delta T. Pretty simple, right? 1 plus 1 is 2, so we get 2 mc delta T. Anyway, so let's relate the two equations. Like I said in the problem, we had to set the kinetic energy equal to Q, so we're going to do that. And we know that, so I just restated the equations right here, both of them. So let's get fancy. This mass and this mass are going to cancel. You're just going to get this equation. V squared is equal to 2 times the specific heat divided by times delta T. Now we got to rearrange it because we're trying to find the change in temperature. So we arrange it, and we get the velocity squared divided by 2 times the specific heat. This is great because we don't need to know the mass of the car. So we just got to Google specific heat of iron. In this case, it is 0.450 grams per or joules per grams. So all we got to do is plug it in now. So we got to convert velocity to meters per second because it's base units. We also got to convert the heat capacity into kilograms because base units is kilograms, right? Not grams. So you just multiply that by 1,000. And then the change in temperature is equal to 0.55 degrees Celsius. And that's about it. Thank you.